Okay, so right now we're going to experiment to see if how the temperatures react when we place a warm solid in cold water. So I have my equipment here. I have a scale. I need a calculator from calculations. I need a beaker, a grad cylinder, our fancy calorimeter, a high resolution thermometer, as well as a metal washer. What we're going to do first is we need to get the mass of the metal washer. So we're going to go over to the scale that is zeroed out. The mass of the washer is 28.14, so you're going to go ahead and record that on your data table. On the back of your data table, you can see that it has a box for your mass for your group number, so just put your mass there. Remember, our mass for this experiment is 28.14 grams. What we're going to do now is we need to heat this washer. I need to be able to calculate its temperature. So is there any way for me to put a thermometer against the washer and get the temperature? Of course, you should say that's no. So what we're going to do, we need to warm this up. So how we're going to warm that is we're going to take our beaker and we're going to go get some water from our hot water bath. So over here, we have hot water. We're going to take this hot water and we're just going to pour the hot water in here. It doesn't matter the volume of the hot water because what we're simply using the water for is to warm up our washer. So we have the mass of our washer. We're now just going to warm it up. Well, that's going to be warming for several minutes. What we're going to do is we're going to need to move on to the next step. We need to get our cold water. So we need to calculate some cold water. This water, we didn't care how much it was because it's simply using to get those molecules of the metal sped up. I'm going to transfer that energy over. So what I'm going to need is I'm going to need an equal mass of water. So since we know the density of water is 1 gram per 1 cubic centimeters, if I need, our mass was 38, whatever our mass was previously, I'm sorry I didn't write it down, you're going to use that same mass in here. Okay, I'm sorry. I remassed the washer, and the washer has a mass of 28.13 grams. I wrote it down now. So we're going to need 28 grams of water. So since water's density is 1 gram for every cubic centimeter, we're going to just get 28 milliliters or cubic centimeters of water. Okay, so I got my water, and we can see by reading the meniscus, we can see down here is 20. And if you go up, we have exactly 28. Our mass of our washer was 28.13, so it's a little bit over 28. Do the best that we can with our tools. So what we're going to do is we're going to pull the room temperature, or the water freshly from the faucet, is going to go in the calorimeter. Remember, this is just to use as an insulator. So what we're going to do first is we're going to need to take the temperature of this cold water. If we take the temperature of the metal washer first, it's going to continue to change, so our results really won't be as good as we want to get it. Okay, make sure the bulb is submerged. Kind of read the thermometer. The temperature of the water is looking to be 20.5. Okay, so we're going to go ahead and record our data. The initial temperature of the cold water, we're going to go ahead and just say 20.5. So we're going to take our temperature thermometer from our cold water, submerge it in the warm water, and we should see that it's changing. Alright, so we're just going to continue to watch it. You can see right now it's about 46, and it'll continue to drop because what's going on right now, the particles inside of the water are very excited, so they're bouncing off and they're transferring their energy to the washer. So we'll know that the washer and the water are the same temperature whenever we see this temperature stop decreasing. That means that all of the energy has been transferred and they have equal amount of energy. So I'm going to pause it and we'll come back when the thermometer stops changing. Alright, it's been about 5 minutes. We're going to go ahead and just say that it stopped changing. So we're going to say that the starting temperature of the metal washer, we're just going to say it was 42.5. So we're going to go back over here. The starting temperature of the warm water was 42.5. 42.5 degrees Celsius. So what we're going to do now is we're going to take our thermometer out, sit on the table for a second. We're going to take our metal washer, which has the temperature right now of 42.5, and we're going to put it in water, which we already measured has a temperature of 20.5. We're going to submerge it, close the calorimeter, and then now we're going to watch the temperature transfer between these two. We see it's quickly changing. Okay, I'll just pause it here and then I'll come back whenever it's finished. Alright, again, it has been several minutes and the temperature stopped changing, so all the energy has been transferred. We're going to record the final temperature. It's looking like exactly 24 degrees Celsius. So we're going to go over here. So now we have the final temperature of the water, and we're going to say it's 24 degrees Celsius. So what we're going to do now is we're going to take our initial and our final, and we're going to be able to calculate the decrease in temperature of the warm, as well as the increase in temperature of the cold, and then we're going to calculate the specific heat of the metal using the thermal energy equations. So calculate that, and then look at the blog posting to tell you how to walk through to find the specific heat, as well as answer the Blue Dot questions number 4 and 5 at the bottom of the paper.